For this problem, we're asked what is the low frequency voltage gain for the amplifier shown at 27 degrees C with RC, RE, and RB values. We are also given our IC, beta, and VT. We're to neglect the effect of bass width modulation, and the answer is given to us right here, but it's important to know how to solve it. So we want to look at the notes that are linked below the like button in the description on about page 138. We have our common emitter amplifier, and that's about the same thing that we have right here. We have this, and we can scroll down a little bit farther. We are going to find some notes here, and then we can also find some equations. Now, we want to find the voltage gain. So that is going to be using this equation right here. So we can take this and we can place it into what we're solving. Now, there are a few things missing with this. So even though we have this, we don't have everything. And this is how we would solve our pi. It's in the same page. And so to do this, we are going to set our pi equal to our V1 over IB. Now, we don't know our V1 or our IB here, so we're going to have to make some substitutions. Well, we know our IB is equal to I divided by beta for that second part. So this is going to be V1 over I over beta. Now, our V1 is going to be equal to I over GM. So that means we could substitute this in for I over GM over I over beta. Now, from here, we can just multiply both the top and bottom by 1 over I, or multiply the reciprocal of the bottom to the top, and then we're just going to get beta over GM. This is equal to our pi. So that is how we would solve for that. Now, plugging in our values, we are going to get 51 over our GM. So now we need to find our GM, because we don't know what our GM is. Well, if we look at the notes again, this one is super easy. The GM is just going to be I naught over VI. And we need to rewrite this for our equation. The I naught is going to be equivalent to our IC, and then our VI is going to be equivalent to VT. So if we plug these values in, we are going to get that we have a 946 times 10 to the negative 6 divided by a 26 times 10 to the negative 3. And if we plug this into the calculator, we're going to get about 36.385 milliamps. And this is our GM. So we can take this GM and we're going to plug it into this equation, 36.385 times 10 negative 3. And this is underneath our beta, which is 51. And this is going to give us an R pi equal to approximately 1.4, and this is in kilo ohms for resistance. Now we're going to take our R pi, we're going to plug it into here, and we are going to take our beta, plug it into here. We're given our R naught. This is really, think of it as RC for how we have this problem. We have our RB given to us, we have our beta plus 1, and then we also have an RE. So after we do all of this math, we're going to get approximately negative 3.43, and this is our AV right here. So that's how we would go about solving for this problem. Now, if we want more, we could find our resistors right here, and we can also find if our VA is 100 volts, and then we have an example right here, and these are from professor's notes, and we will use these equations to solve for them as well. So that's how we go about looking at this problem.